My name is Lauren Thompson. I am currently a mechanical engineering student at Georgia Tech. I'm enrolled in ME 3210 Design Materials and Manufacture, instructed by Dr. Rashidi in fall of 2024. This video is for educational purposes only. This is my design for an improvement on wheelchair accessible desk attachments. Imagine this scenario. You are a handicapped student and you walk into the first day of class to see that all the chairs look like this. They automatically have desk attachments that cannot be taken off. There is not a singular table or regular desk for you to sit at. You would need to request an additional accommodation or else there would be no place to write. This is inconvenient and could potentially cause someone to be uncomfortable. While there are some current models of handicapped desk attachments, most of them have a lot of flaws. For example, this current model is not versatile, not ergonomic, and has attachment issues, and additionally is inconvenient. The only way to collapse this model to make it transportable is to unscrew the posts that connect to the wheelchair arms. Additionally, how is a student who will already be having their backpack on their lap and wheeling themselves around be able to transport this desk attachment as well? Similarly, this model velcros onto the wheelchair arms. This model is additionally bulky and awkward, would be extremely hard to carry around, and might not fit all wheelchairs. Therefore, this model is also inconvenient, awkward, not versatile, not ergonomic, has attachment issues, and this also is a $50 model. Because of these issues, I am proposing a new solution. I have redesigned a collapsible and more ergonomic, portable, accessible desk attachment. What sets my redesign apart is the ability to conveniently collapse and attach this desk to the back of any wheelchair. Let's take a look at some specific improved features with detailed descriptions. The desk comes with a new feature that allows to attach to the back of any wheelchair. This is a close-up of that feature on the bottom of the desk. Locking hinges allow for the legs of the desk to open and close. This allows the desk to become easily transportable and collapsible. Here is what those legs look like, both opened and closed. Lastly, a connector piece that assembles onto the legs is height adjustable and can therefore attach to a variety of different arms on wheelchairs. Here are some final views of my redesign from the front, where you can see the entire assembly together, as well as a top view. I have provided a rendered image of what this desk attachment might look like on a real-life wheelchair. Here is a rendered view of the collapsed version of my redesign conveniently attached to the back of a wheelchair. Now let's look at a direct comparison of the legs of my redesign and the legs of one of the designs already implemented. Rather than having the legs attach and detach and be a burden to carry around, my legs are able to swing up and down to collapse while staying attached via the locking hinges. Now let's compare the redesign attaching mechanism to the second design I showed. The second design velcros on the wheelchair's arms. This is bulky and awkward to transport and a burden to attach. The redesign is significantly easier to attach using the newly designed connector pieces. For another direct comparison, it is evident that the models that already exist do not have an easy way to be transported. My redesign easily attaches to the back of any wheelchair. This increases efficiency of use, makes the product more ergonomic and easy to transport. To reiterate some of the specific benefits and advantages of my redesign, it is more ergonomic, increases ease of use and convenience, improves accessibility, can be used for a wider variety of applications, is easier to transport, lightweight, and increases comfortability for the user. Let's expand the scope of application for my redesign. Not only can my redesign be implemented on a variety of different wheelchair types, it can be implemented on a variety of different chair types as well. As you can see by the middle image here, my redesign would fit perfectly on the back of this chair, and then can be used as a desk for anyone. Here is another example of a chair that this desk attachment would perfectly work on. Notice how my redesign would easily be able to attach to the arms of this chair, as well as collapse and attach to the back of this chair. Additionally, it is worthwhile to note that any person at any time may experience a lower body injury that might subject them to be temporarily in a wheelchair. Therefore, my redesign is highly versatile and can be used by anyone in a variety of different situations. Now I can discuss the manufacturing processes and materials used to create this redesign. First and foremost, this design needs to be lightweight and durable. Therefore, the majority of the components will be made out of plastics. The top of the desk will be made out of plastic ABS. It will be produced via injection molding because it is good for high volume production, complex geometry, allows for smooth finishes, consistency. Large molds are possible with injection molding. Injection molding is additionally cost-effective and efficient. The legs will also be made out of plastic ABS using an extrusion approach. Extrusion is efficient, it has good strength properties for lightweight materials like plastic, it is also consistent, it has good flexibility for desired shapes, and is a cost-effective process. The locking hinges will be made out of polycarbonate because they need to be a high-quality engineering plastic for durability and strength purposes since these are dynamic elements. Injection molding is the best process because it is good for high volume production, complex geometry with smooth finishes, consistency, has large molds possible, is cost effective, and efficient. Lastly, the connector pieces for the arms will also be made out of plastic ABS via injection molding, because injection molding once again is good for high volume production, complex geometry with smooth finishes, consistency is cost effective and efficient. In order to assemble the different pieces, plastic fasteners and rivets for pre-modeled holes can connect the pieces together. Plastic fasteners and rivets are easy to use, lightweight, cost-effective, efficient, consistent, and good for high-volume production. Before finishing up, it is crucial to mention the possible redesign disadvantages. These disadvantages include potential issues with longevity and durability due to the use of plastic components. Additionally, this design is applicable to many wheelchair types, but it might not be universally applicable to all. There may be stability concerns when it comes to putting stress on the legs and supporting unevenly distributed loads due to the design of the legs and the use of plastic. The connector pieces may additionally be a less stable form of attachment, and lastly, the redesign may have poor aesthetics due to the use of cheap plastic. The resources I used for this project include Manufacturing Process for Engineering Materials by Sirope and Stephen, and various lectures by the course instructor Dr. Rashidi. I would once again like to remind you that this project and presentation is for educational purposes only. Thank you for watching my presentation. I hope you enjoyed it.